Welcome to the Terminology Leading Practices stream of SNOMED Expo 2020. My name is Dr. Jim Case, and I'm Head of Terminology at SNOMED International. I will be moderating today's session. During the session, please use the question and answer box to type your questions to the presenters. Questions will then be answered at the conclusion of the presentation. I'm now pleased to introduce Monica Harry, Cathy Richardson, and Peter Williams from the Product and Services Group at SNOMED International, who will be presenting SNOMED Quality Initiative Project Update. Monica, please proceed.
Yeah, thanks, Jim. Hi, everybody. My name is Monica Harry. I lead up the content and mapping team at SNOMED International. And as mentioned, I'm going to present today the Quality Initiative Update along with my colleague Cathy Richardson and our teammate Peter Williams. So I'm going to tell you a bit about the reasons for the project, the objectives of the project, and outline the benefits. Cathy's going to talk to you about the work we've done to date, the modeling changes we've actioned, and the outcomes so far, and she'll give you some examples to help you understand the work. Peter, in turn, is going to discuss the progress of the project, the methods we have for reporting and assessing that same progress. Next slide. So you might well ask, why are we doing this? So to give you a bit of background, SNOMED came into being as a result of the union of codes used in the United Kingdom owned by the National Health Service. They were called Clinical Terms Version 3. Also, you might hear people refer to CTV3. They were joined with codes used in the United States by the American College of Pathologists. That was known as SNOMED RT. It's a wee bit confusing, but now we're SNOMED CT, and it's a combination of those two source terminologies that resulted in what you see today. After the merger, the source from UK NHS and the CAP source terminologies, the initial release of SNOMED CT contained over 300,000 concepts, and it was first released in January 2002. Since then, the regular updates of SNOMED have been every 6 months. And if you consider in the past the technology, believe it or not, authors, well, it may not mean anything if you don't author concepts, but using current tooling, we can do what we call classifying and see changes as many times as we want in a single task. Back in the day, they could only classify once a day. Hence, the focus at that time was on adding content. Over the intervening years, SNOMED has developed sophisticated tooling specifically to create and maintain SNOMED CT. And if you think generally in the world of technology, the advancements are such that building and maintaining any database, not just SNOMED, is more manageable. Additionally, we now have what we call description logic, which is the formal foundation of meaning in SNOMED CT. It's the way that concepts are modeled using description logic that permits us to then hand it over to the reasoner in the background, the classifier, which basically helps test the expressions for subsumption and equivalence and make sure that all the concepts end up in the right place in the terminology, the right meaning in the right place and related to all the other concepts that are relevant. So why are we doing this? Basically, there are persistent legacy issues. As I mentioned, focus in the past was on adding content. Today, the focus is on quality. Not to say their focus wasn't quality, but it was just much harder to manage. And I mentioned already about the description logic reasoner, which helps us today in our world to manage the terminology in a much more efficient manner. Additionally, in the authoring platform, reports can run ad hoc, which allow us to identify duplicates, show where a foundational concept, such as body structure or associated morphology, is in use to define other concepts. Overall, we have the tooling that gives us a better picture of the terminology and how it's arranged. Comparing that to 10 years ago, as I mentioned, it was a much bigger challenge in the past. We also now have much better editorial policy, editorial guidance. We have the machine-readable concept model, which really gives us all the rules around the attributes and the values that can be applied to define concepts. So our aim and the benefits, really, what we're aiming to do and the benefits we hope to provide are to maximize the number of sufficiently defined concepts, maximize the number of concepts that comply to a template, which gives us a degree of assurance that they are actually modeled properly. And additionally, the templates follow are guided by our what we call our concept model. And the concept model is what lines identifies or are the rules governing what can be in a concept, you know, the attributes, the values, etc. So the next slide, I think I have a couple more and then I'll hand over to Cathy. So basically, in a nutshell, with more sophisticated tooling and a large authoring team, we now have the ability to perform the due diligence that's required to ensure the structural consistency of the concept. And yeah, just actually, I should actually mention the fact that that is the focus of the QI project, is more about structural integrity and that the concepts are in the right place in the hierarchy, more so than looking at clinical validity and quality, although that does happen in other areas. So I'm going to hand over to Cathy now, and she's going to tell you about the work we've been doing and give you some examples.
Thank you, Monica. So I'm Cathy, and I'm focusing on the sections of the content that we've done work on and some examples of those improvements. So work's continued this year on the simple concepts in the clinical finding hierarchy. Now, when we started the quality initiative, areas of work were identified by a sub-hierarchy approach. For example, the sub-hierarchy cyst disorder was one such area that used that approach. In early 2020, we progressed to a second stream of work focusing on identifying clinical finding concepts that are modelled with a specific attribute. The associated morphology attribute is the first of these. With this approach, the subtypes in the clinical finding hierarchy that are modelled with the associated morphology attribute with a particular range of morphologic abnormality values, for example, protrusion or subtypes of protrusion, are identified as an area of work. Now, when doing this, concepts that have been reviewed in the past under our sub-hierarchy approach are excluded from the work area. Now, this slide just shows some of the areas within the clinical finding hierarchy that were completed in 2020. For example, the clinical finding concepts that were modelled with the associated morphology attribute that had a value of narrowing or a subtype of narrowing have now been through the QI process, and you can see some of the others here: fluid disturbance, pigment alteration. Now let's look at three specific examples from the QI work that have shown some, we can show some improvements with. So the first one here is a sub-hierarchy example where we picked the sub-hierarchy of angioedema and or urticaria. So this piece of work was done earlier before the changeover. Now the concept angioedema and or urticaria was primitive, and the sub-hierarchy only had 41 descendants. Now, as part of the QI work, this particular concept was remodelled using GCI. So it's still a primitive concept, but two general concept inclusions were added, which enables it to inherit subtypes. Now, in addition to that, a new morphology value was added, angioedema, and subtypes were remodelled. As a result of all the work in this area, the sub-hierarchy now has 115 descendants. Now, this work was done for the July 2020 release, so you'll be able to see it in the browser if you went to have a look. Okay, let's have a look at the second example. Now, this time we're going to have a look at the concept osteophyte of right knee disorder. Now, this concept had the correct proximal primitive parent and the correct associated morphology attribute and value, but the finding site on this particular concept was structure of right knee region, and that's broader in meaning than the anatomical site represented by the FSN. So an osteophyte occurs on the bone. It's a bone spur, and so we need a more specific finding site for the bone of the right knee. Now, as a result of this broader finding site, osteophyte of right knee was not subsuming as a subtype of osteophyte bone, and it didn't have any subtypes. So, as part of the QI work, the finding site was corrected here to bone structure of right knee, and that resolved the issue. And if you look at the inferred view on the right side of the screen, you can see it's now correctly inferring as a subtype of osteophyte of bone. It's picked up an additional parent of massive knee finding, and it also has an inferred subtype, osteophyte of bilateral knees. Now, our final example is the disorder concept neoplasm of blood vessel of hip. Now, this concept had two stated defined parents, one of which was actually incorrect, neoplasm of blood vessel of trunk. Now, as a result of this, that concept was sitting as a subtype of neoplasm of blood vessel of trunk, and it also had an incorrectly inferred second relationship group, and you can see it here on the slide. Now, SNOMED International uses a proximal primitive parent modelling approach, and so this concept was remodelled using this, and the stated proximal primitive parent became disease. The classifier, when it was run, resulted in the fact that the concept neoplasm of blood vessel of trunk was no longer one of the supertypes present, and the second relationship group, the second incorrectly inferred one, was gone. In addition to that, the modelling change also resulted in 3 subtypes. So these concepts that should have been subtypes of it weren't, and now they were because of the correction. Now that brings me to the end of my section, and I'll pass you over to Peter.
Thank you, Cathy. Hello, my name is Peter Groves-Williams, and I've been providing technical support to the QI project since its inception in April 2018. So what I'd like to do today is work through a couple of questions that came up in early September when I ran our key performance indicators and had to ask what the heck's going on there. And you know I'm only going to do that not when the numbers start to look bad, because it's human nature to not go asking a lot of questions when things are looking good. Now, these KPIs for intermediate primitives and role group crossovers were in place before the QI project started, and they're part of the reason for QI to exist, as we try to move the inconsistencies that show up in role group crossovers and the maintenance headache that intermediate primitives cause. It looks great that our role group inconsistencies on the second line there disappeared completely in January 2020, but in fact what happened was, when we switched to expressing our stated form in AL, we started self-grouping attributes. So those problems just jumped up to the top line, which is why that number goes up by 18%. The count of the two added together shows continual improvement. And what we see a massive drop in stated intermediate primitives in July 2019, down 14%. Remember, that's a percentage over the whole of SNOMED CT. And given that the QI project has restricted itself to clinical findings, that gives you a sense of how big clinical findings actually is. It's 32% of SNOMED CT. This pie chart comes from our release stats page, which you're welcome to have a look at if you navigate to browser.ihgseotools.org/QA. Then we've pages that show the breakdown of the hierarchies, as well as counts of new and modified components in the most recent release. So if we're doing all this work to clean up intermediate primitives, which is what we see in the stats related to the stated view, then why does that number go up in the inferred view? That is, after we've run the classifier and concepts have found their correct place in the hierarchy and been given the most specific parents that could be found for them. Well, it's the result of the proximal primitive modeling style we've chosen to author concepts to, and we're the victims of our own success here. In the stated view, you can see the proximal primitive parent has been correctly set as disease. There's no sufficiently defined concept above fracture of 6 ribs, so it would not be identified as an intermediate primitive. And this is how proximal primitive modeling is supposed to work. We state the most general possible parent along with the most specific attributes, and the classifier does all that heavy lifting for us, working out all the hierarchy and parent-child relationships in the inferred view. And the thing that's making these concepts suddenly appear to be intermediate primitives is the fact that they have sufficiently defined children. So when they move into their correct location at the bottom of a huge pile of sufficiently defined parents, they show up as intermediate primitives because they're sticking out like sore thumbs with sufficiently defined children above and below. Whereas in the stated view, there were only primitive concepts as parents. So the fact that we have an intermediate primitive waiting to happen is hidden from us until we classify. And as we move more and more concepts into this proximal primitive parent style, we're going to see more of this. So I would argue that in the stated view, we've only managed to hide the problem by the virtue of proximal primitive modeling and our definition of how we spot intermediate primitives. And that really, if we've not fixed the intermediate primitive in the inferred form, we've not fixed it at all. But even saying that stated concepts don't look like intermediate primitives and can become them in the inferred form, and worse, are hidden as intermediate primitives when we move to the inferred form, until we move to the inferred form, we still have an overall increase in intermediate primitives. Well, the reason those numbers are going up as we're adding more and more content correctly aligned to the appropriate template and marked as sufficiently defined is that every primitive concept above it, and that might have been innocently sitting around as a leaf node and not causing anyone a problem, is suddenly being identified as an intermediate primitive and another problem to be solved. And this is why one of our senior terminologists, Yongxin Gao, has been pushing me to include leaf nodes in the definition of intermediate primitives, because really that's what they are. They just don't know they've got a problem until they've got children, which is something I can relate to on a personal level. So I did some analysis to break down these newly appearing intermediate primitives. And here we are, 71% of new intermediate primitives appeared in the last release in the body structure hierarchy. But what I'm interested in is how it's happening in the disorder hierarchy, where the QI project is active. So at that point, we need to look at some examples. So we'll have to look at a few more of these to be sure, but just to pick a couple at random. Sterile entomyophytis, if we look before and after, we see that, as suspected, sufficiently defined children have been added to an existing primitive leaf node, turning it into an intermediate primitive. Ocular hypertension, same thing. I was using the NHS UK SNOMED browser in order to see our previous release, and we see that any children there are all primitive. But in the latest release, we've added a sufficiently defined child, which is all great work, aligns to the appropriate template, but it causes a primitive leaf node to become an intermediate primitive, and our KPI stats take a hit. So just to give you a break from the white knuckle ride of raw numbers and KPIs heading in the wrong direction, I thought I'd show you where those numbers came from, which is our reporting platform that allows terminologists to run their own reports against whatever project they're working on. We're pushed for time, so I'll just show these in passing. But to say the release stats report here is where I get the KPI numbers for crossovers, intermediate primitives, and our percentage of concepts that are sufficiently defined. The reporting platform is broken down into categories, grouping 5 to 10 reports together. And this last one is the QI section, where we run template compliance. So the KPIs I showed earlier were existing metrics that we were already using as a particular way to look at the quality of SNOMED CT. But when we started QI, we were really focused on bringing concepts into line with editorial policy and a reasonably small number of templates. And at that point, the obvious question is how much of our content aligns to the templates we've specified. And the tricky thing about running those metrics over time is that we're changing two things at once. Yes, we're improving the content to bring that into line with the templates, but we're also specifying the templates. So it might be that we have concepts in SNOMED that are modeled perfectly fine, but if we haven't got around to saying what the template for that area should look like, then that's not going to show up in our stats. So to try and focus on just what the improvements to the content is, these numbers here have been produced by taking all the templates we've identified to date and going back to see how the content aligned to those historically. And again, I've got a whole load of investigation to do, because January 2018 to July 2019, the numbers show we're making great progress with the percentage of content that aligns to templates. And then as we come into this year, it looks like we've made no percentage progress at all, and we're slipping back. So I didn't like those numbers. Fortunately, I didn't have to look very far, because if you look at the raw count of concepts that conform to a template, they show an increase every release. The problem, or the reason why those numbers start to look bad, is that although we've added 1,800 new concepts into SNOMED, 7,900 concepts have become in scope as far as the QI project is concerned, and the percentage goes down. Now, we're pretty sure they're not moving between hierarchies, so it must be because they've been given attributes where no attributes were previously specified. This is one of the criteria for being in scope for the QI project, that there must be some sort of model present. So I had to go back to my reports, this time the summary component stats report that I did for Andrew Atkinson, our release manager, and add a new QI tab to ask the question, what concepts that existed in the previous release now have some sort of model, some attributes, where there were none before? And here's our answer. Someone, and that someone could only be senior terminologist Yongsheng Gao, has been adding attributes to concepts that have never had attributes before. Curse his efficiency. The problem for the QI stats is that the report didn't have access to a body structure template. So the next step here will be to identify the template that these new attributes feature in, rerun those stats, and our numbers will look much better. So just to conclude, I thought I should say something about our progress. We started in 2018 looking at individual sub-hierarchies, and we got as much juice as we could from squeezing that lemon. And now we've moved on to working with groups of concepts selected by expression constraints, because those concepts we're interested in, that adhere to a single template, might appear across several local sub-hierarchies, but they all have attributes in common. We've previously shown progress has been at over 50% of clinical findings, but those numbers were calculated by adding up concepts processed and didn't take into account where there was overlap between sub-hierarchies. These percentages here have been calculated using a huge ECL of everything that's been looked at, which removes any double counting. Currently, we're working on specific morphologies, and after we've exhausted those, we'll look at causative agent, followed by finding site, again staying within the clinical findings hierarchy. Once we finish the first class of clinical findings, the plan is to move on to procedures. Medicinal product already aligns with templates due to the work of Tony Morrison and others in the drug project. So when we added the template for clinical drugs, our compliance stats took a huge boost, jumping from 20 to 25% compliance. Other hierarchies we consider in scope are body structure, situation with explicit context, specimen, observable entity, and event. And that concludes my presentation. I will hand you back to Jim. Thank you.
Thank you, Monica and Peter and Cathy, for your presentation. May I ask that attendees give us a moment while we switch over from our pre-recorded content so that the presenters can address the questions that you've been submitting live. Please also note that this session will be available on the event platform for the next 3 months. Welcome to the live Q&A portion of this presentation. First of all, I'd like to thank Monica and Peter and Cathy for their presentation. And we have a couple of questions in our queue here. First question is it possible to volunteer to participate in quality revision of branches of the international edition?
Thanks, Jim. I can answer that question. Hello, everybody. Thanks for joining our session. I hope it was informative and useful. With regard to reviewing the work that we're doing in the Quality Initiative, at this time that's an internal project, so we don't actually have external people reviewing that. However, if at any time you want to submit a request for change, you're welcome to do that, and we will consider that under the auspices of the Quality Initiative if it concerns clinical finding concepts. And as always, the browser online has what we call the daily build, where you can see changes almost as they're happening. I hope that answers the question. If it doesn't, feel free to type again.
Thank you, Monica.
Yeah.
So the second question is, have there been efforts to increase the throughput of review? For instance, trying to leverage a model to predict the modeling or editorial based on the FSN, so the reviewer can just approve a suggestion, at least in some cases, rather than manually fix from scratch.
Can I answer that one?
Peter, do you want me to answer this one, or?
No, I'm happy to take that one. We have not used lexical methods in this process yet. I wouldn't say that the authors are fixing these from scratch. We do have support from batch processes, and that's a large part of why we're doing this work, because if we can bring these concepts into alignment with a template so that a whole set of concepts is structured roughly the same, then we can start to use these batch processes on them. I'd certainly be very interested in hearing about that if there are projects out there that have had results on this. Personally, I find it very difficult to get anything better than 30% from a lexical model. And we are running things with taking the template, looking at the inferred view, and then picking the best things and removing the redundancies and so on. And that has had some success, but it could also cause problems. So it's not a silver bullet by any means. Thank you.
Can I just add to that, Peter? I would say that from your standards are high. From an authoring standpoint, using the templates and running checks and balances using the template language as a query to identify those concepts that are or are not aligned actually speeds the process up for us. We get a lot more done in that automated fashion than if we were manually going through each concept. So it's not ideal, but it's certainly, I would say that we're partly there, towards leveraging the model to predict the changes, not predict, but identify, see them at a glance rather than one by one.
Thanks, Monica. The next question is, how is review prioritized? For instance, 54% of clinical findings are left to do. Is there an approach to prioritizing the 54% to do the most impactful first?
I would say our approach to prioritizing generally was to work on that area of content that we understood to be the most frequently used and clinically useful, if I can answer it that way. And that's how we're still, well, we've gone through the bulk of, I'd say, chronic diseases. Now we're looking at, we're approaching it via morphology. So for example, I'm working on the area of mechanical lesion, which covers embolus. Jim's working on injury. It's not actually easy to decide the best way to prioritize. We've looked at different ways.
Thanks, Monica.
Mm-hmm.
Our next question is, thanks for the update. You're my favorite project. Which areas of templates are you going to focus on for the next release?
Thanks, Kate. That is an ongoing discussion that we have, but we're still finishing up clinical findings. But the next is going to be procedures, which you'll love, and we need your input for that for sure.
So those are all the questions that we have. We can wait a minute or so to see if there are any other questions coming in. So at this point, we just stand by and wait to see if somebody else has a question.
Can I just mention that the pages where we track our progress and list which hierarchies or which areas have been worked on is, I believe, open to people to review and look at. As well, we do publish on the early visibility page any major structural changes that we believe will impact people. So if you don't have that information, you can send me an email and I can give you the links to the pages I'm talking about.
And I think just as an additional piece of information for users is if you have access to the daily build, you can actually follow some of the progress as the QI sub-projects get promoted up to the daily build browser. So we don't have any additional questions, and we're running out of time here. I want to thank Monica and Peter again for this, and I hope that this was informative for all users. Thank you.
There's one last question came in, Jim. I'll take 2 seconds to answer it. There is actually a separate project, Marie, for anatomy. That's a separate project that's being worked on by a team internally. So we're not looking at body structures separately. Thanks. Thank you. Thanks, Jim.
Thank you, everyone.